Generative AI functions like a digital parrot. Its processing stops entirely the second a user stops providing prompts. Agentic AI shifts this dynamic by reasoning and acting across multiple steps to reach an objective. Handling complex, multi-day workflows is why analysts expect agents to outnumber human sales teams 10 to 1, aiming for a £400 billion UK growth target by 2030. Despite that projection, a significant gap remains between experimentation and results. While 62% of organizations are testing AI agents, fewer than a quarter have successfully scaled them in any single business function. To understand why these pilots fail and how the 2030 economy will actually function, we have to look at the mechanical shift from simple generation to autonomous agency. Mastering the internal software architecture of these agents is the baseline for participating in this upcoming economic shift. Agentic AI moves beyond conversational prompts, operating instead under a broad, overarching objective. Given a goal, the model shatters the objective into a downward branching tree of interconnected microtasks. It resolves each node through continuous internal querying, calculating subsequent steps without human input. This relentless logic loop exerts a computational toll, requiring constant server power to sustain reasoning. The International Energy Agency links this always-on compute demand to a global trend. Data center electricity consumption will more than double by 2030. The adoption of agentic systems creates a physical infrastructure constraint tied directly to the limits of our power grids. During the acting and adjusting phase, the agent executes its microtasks and evaluates the real-world outcome without external guidance. If an action fails, the system recognizes the error, loops backward to recalculate a new pathway, and proceeds forward. This autonomy introduces a structural vulnerability. Without human intervention, bad data or poor risk controls will cascade instantly across the logic loop. These cascading failures explain why 30% of generative and agentic projects are quietly abandoned after the proof of concept stage. This failure rate has led to agent-washing, where vendors rebrand basic automation to inflate capabilities, masking an inability to handle real-world complexity. Success in deployment depends on navigating the compounding risk of autonomous decisions at an enterprise scale. Because the software acts independently, the primary enterprise challenge shifts from software engineering into corporate governance and liability. IBM research indicates that formal governance is the deciding factor in project survival. Companies that implement audit trails and human sign-off thresholds see a 5% higher return on their AI investments. Automation on this scale changes the global workforce. The World Economic Forum predicts 92 million jobs will be displaced by 2030 as agents take over transactional tasks. While 170 million new roles will emerge, they require expertise in designing guardrails and auditing autonomous decisions. By 2030, Agentic AI functions as a vast infrastructure system that entire organizations must learn to actively govern and manage.